In this video, I'd like to cover reference assemblies in .NET, what they are and why they are useful. Let's just jump into a demo. I have a simple solution here with a console application. Very simple, just a console application that depends on a library. That library depends on the next library, and it sort of forms a chain and it mixes between F# and C#. Now, because we're going to talk about reference assemblies and I'm targeting the .NET 7 SDK, they're actually enabled by default. So I'm going to use a directory build props file to just disable reference assemblies to show you sort of the before and after situation. So reference assemblies are disabled. If I built the console project, everything should be built by now. And let's just start over there. When we look into a library, all the libraries have a function that returns a version, which is a string. And if I change this version to something new, because I'm changing library 4, which library 3 depends on, which library 3 changes, library 2 depends on, etc. When I'm building the console application, I'm actually going to build all the projects because of a change at the end of the chain. So when we look for a core compile in our MS build output, we find that it's going to invoke the C# compiler for the first project, which is library 4. Then it's going for library 3, which is in the F#, using the FCS binary. And then again, library 2 is C#, library 1 is again in F#, and the console application is F# as well. But when you think about it, the change we just made by changing the implementation didn't really change the public API of library 4. So from a certain point of view, library 3 and onwards, they didn't really get any change. There was no new information for library 3 to compile its code. And that's where reference assemblies actually come in. So now I'm just going to enable them by changing my props file. I'm just going to put them on explicitly. So again, in .NET 7, when you're targeting .NET 7 as framework, it will be enabled by default, but we're just going to put it on explicitly. And when we build our console, it will need to rebuild everything because we changed one of the properties. When we change library 4 again and build the console application, we will notice that core compile kicks in for project 4, but then the next is going to be skipped because there's no new information for library 3 to compile itself. And then the same for library 2, library 1, and then the console application. And that's really where reference assemblies are a powerful instrument, as they help you in incremental compilation for your projects. When I look at library 3, I notice that I have a private field over here, and then I also have a version function. And now let's take a look in how does the reference assembly look like in ILSpy. So when I open it, just clear everything and open it up. Notice that going into library 3 in the object folder, we now have a ref and a refint. We previously didn't have that when we didn't enable reference assemblies. Refint is the intermediate folder for reference assemblies. So the reference assembly is first going to be written down here, and if it differs with your assembly over here, it's going to be copied over there. It's just a bit of an internal detail. But when I open a reference assembly, notice that I'll see my code over here, but instead of returning a string, it actually throws an NOLL. And that's because a reference assembly doesn't really contain any private details or implementation details. It just tells you what the public API is. And that also helps in compilation that the assembly will be a lot smaller than the actual implementation because it doesn't have all those details. It does, however, have sufficient details for library 2 and onwards to compile itself. Notice that we have this version function, but when we open the real assembly, we again have more details, as in version now has an implementation. So this is the result of compiling a string interpolation in F#. And then it has this private field, private value v as well in the actual assembly, but that's not present in the reference assembly. Now every reference assembly also has something that's called a module version ID, which is a GUID. I have a little helper function that will print the module version ID or MVID for short. And this is a GUID that represents a fingerprint of your public API. In short, if your GUID is different, then your public API will be different. So if we now add a new public function, being very specific with the public here, if we build library tree again, notice also that the compiler flag was added because we specified in our props file that we want reference assemblies that's being passed on to the F# compiler, that it says, hey, you need to actually output the reference assembly in this location. And if we then run the getMvid function again, which just reads one of the header properties of the assembly, we'll notice that we'll have a different mvid. When we change a private implementation of our mvid and build again, our mvid remains the same. I do want to highlight that the mvid for an F# assembly isn't overly stable at the time of recording. So for example, when I add a new private field to the file, and when I build, this shouldn't, conceptually this shouldn't produce any new mvid, but it actually will, and that's because of a limitation in F# at the time of recording in .NET 7. So this produces a different mvid. And part of that is because in F# there's a bit more information stored in the assembly. Some extra information is stored as resources, and those eventually lead to a different mvid. Please express your interest in this if you want to see this fixed or improved over time in the F# compiler. My personal angle in all of this is that together with the gResearch open source team, we have contributed some of the missing pieces that were required for this initial support for reference assemblies in .NET 7 for F#. For us, this was a great example of making a difference in open source. Thanks for watching.